So to convert some of these equations, here's an easy one to convert. Start off easy. The idea would be to just use your algebra skills, and convert means get rid of the t, so that you just have x's and y's, and same as you had in the Cartesian equations. From this one, we can gather that if I take x and subtract 1, I get the same thing as t. So the exchange rate between t and x's is t can be exchanged for x minus 1. So I go on and I substitute this in here. That would give me that y is equal to the quantity x minus 1 squared. Lo and behold, what I've got here is a parametric version of the equation. That's it. This is parametric, this is Cartesian, that's parametric, and that's us converting them. We might want to convert also the signs and the circles and ellipses just for fun, and see how that goes. For the circle, it's not such a good idea to isolate t and then plug it back over here. You might want to use a different idea here. For example, the idea of squaring them. I know that if I have a cosine square and a sine square, I can exchange those for a 1 because it's a famous trig identity. But I don't have a square here, I just have a plain cosine. So I could square both sides and fix that. That would give me that x squared is equal to cosine squared t. This one would give me that y squared is equal to a sine squared t. Now we go on and we add these together. We add them. On the left hand side I have x squared plus y squared. On the right hand side I have cosine squared t plus a sine squared t. Whoa, at first you might think we just made it more complicated. But look, this is a famous identity. That one right there is equal to 1, and so we have ourselves a nicely converted expression for the circle. I told you this one was a circle. Now you see it as something more familiar, possibly. Hopefully this is more familiar to you. Standard equation of a circle with radius 1. Okay, try that again on the ellipse just for fun. What if we go on and do the one that has a 5 and the 3 there? The other one didn't have any of those. That poses a different problem, because if you square it, you'll get 25 and 9, and that's not going to be equal to 1. However, there's an easy fix. I'm sure you could figure it out probably. But if you're a beginner and you want to see it how it's done, you could do this. X over 5 is equal to a cosine t. Therefore x over 5 squared is equal to cosine squared t. This one would say that y over negative 3 is equal to a sine t. Therefore this one squared is equal to that one squared. And then I go on and I add these. I add them together, and on the left hand side I would get x squared over 25 plus y squared over 9, and on the right hand side I would get, of course, just a 1. And so we have converted the famous parametric equations for ellipses. We see that it's equal to the standard or the well-known form for ellipses. Okay, easy, right? You can do this. So then what comes next? Well, then we should talk a little bit about the greatest, most amazing parametric equation in the world, in the universe.